In this lesson, we're going to talk about measures of central tendency. We're going to review mean, median, and mode, which you should already know from previous classes. I'm going to go through it quickly. Um, we are going to then learn how to calculate and interpret a new type of measure of central tendency called expected value. And then we're going to learn to calculate expected values when it is given as a Bernoulli trial or a binomial distribution. It's important to recognize that one because it's a simplified version of the equation. So make sure you pay attention to that part of the video. It saves you a lot of headaches on some harder problems. Okay, so let's start off. Review, mean, median, mode. If you don't know, these are all measures of central tendency. What we mean when we say measure of central tendency is the generic concept of average. In everyday language, we say the word average to mean what would you what would you expect? What is the normal? It's all just, we lump it into one word called average. And we have lots of ways of calculating that. And so it's about which is the best representation for that particular data set. You can calculate mean, median, and mode of any data set, but they may not be an accurate representation or a fair representation. And a lot of times statisticians play games using the wrong measure, or at least what I think would be the wrong measure, to talk about data. So let's just do a very quick review. Using the data set above of shoe sizes. Okay, so these are people's shoe sizes that I surveyed in my class. Find the mean. Okay, so pause the video, find the mean. All right, how do we find mean? Mean is the sum of all of these values. You literally just add them up. And when I did that, I got 94, and then you divide that by the number of numbers, and I count 13 numbers. So therefore, 94 divided by 13 would equal 7.23. So now, what are the units on this? Well, that would be shoe size once again, right? Shoe size. Because all of these is the shoe size of shoe size 1, shoe size 4, shoe size 4. So if I'm adding them up, it would just be the average shoe size. So we'd be saying the average shoe size in this class was a 7.23. Okay. Median. How do you find the median? Well, median means middle. So what we're going to do is, please don't do it the way that you cross off the ends. All right, first you put the numbers in order, right? And they're already in order for you, but you put the numbers in order. Then you say, all right, to find the middle, I'm going to cross off one on each end. All right, and we keep going with this. All right, we're through calculus. We can find a middle just by dividing, right? Dividing by 2. So if there's a total of 13 numbers and we divide that by 2, 13 divided by 2 means our middle is at, what, 6.5? So I'm going to count 6 numbers in. 1, 2, 3, 4, 5, 6. There's my 6th number there. 1, 2, 3, 4, 5, 6. There's my 6th number there. Hey, look at that, 6.5. Half up, half down. That puts me at a median of 6. So therefore I have a median of 6. Okay. Next, mode. Mode is like voting, right? Mode is what happens the most. So we're going to look for, all right, I have 1, 1, I have 2 4s, 1 5, 3 6s. Oop, that seems like a lot. 1 7, 1 10, 3 11s, and 1 12. All right, so the number that occurs the most is 6 and 11. So therefore, this answer actually has 2 modes, or aka it is bimodal. It is a bimodal distribution, but my mode is 6 and 11, and that's okay. You can have 2. If you had 3, it would they tied for. I had 3 that all had the same amount. Like if I had a 12, a 12, and a 12, now I'd be trimodal. All right, it's not a big focus in this class, the naming, but just the idea of mode, which thing happens the most. Okay, so we are looking at a bimodal with values of 6 and 11. All right, which of these is the best representation for shoe sizes in my course? Well, what do you guys think? Well, me personally, I'm thinking this looks the best. Why? Well, when you think about it, there is probably girls and boys in the class, and they tend to have different shoe sizes. So what this is saying to me is, more likely than not, just taking a guess at this, my girls, I had 3 girls in my class that had a shoe size of 6, and I had 3 boys in my class that had a shoe size of 11. Now, that's not, I don't, that's just a guess, doesn't have to be the case. But when you go back and look at the data, you could kind of break it up and say, okay, well, the most common shoe size, if I was to pick somebody out of the class, the average might be 6 and 11. All right, would 7.23 be a good average of the shoe sizes? Yeah, probably not. The likelihood of you picking that out would be very low, near impossible because there was only one 7 in the class and there was no 8s. No, that's not the average. So adding the numbers up and dividing by the number of numbers isn't a great representation. Now, this might be a better representation though if you split it up kind of into boys and girls and then added up the girls' shoe sizes divided by the number of girls, add the boys' shoe sizes divided by the number of boys. That would be a better representation. I purposely didn't do that just to kind of point out that just the average idea of mean being the average is bad, right? It's about when you have to use it appropriately. You have to use it when, whoops, excuse me. You have to use it when it makes sense to use that measure. This is not that situation. Median, again, may be a little better because now you're saying you're the bulk of the class, you went, eliminated the high and the low, and worked your way down. And you found kind of the middle being 6. And that doesn't seem bad because if you were to pull people out of the class, people who are around 6, 5, you have, what, 1, 3, 5 of the 13 numbers are really close to 6. And that's, again, because that's where my girls were located. Anyway, whoops, didn't mean to erase that. Okay, so anyway, let's move along. So that was just a review. Those are all measures of central tendency. They all mean the concept of average, and you just have to know which one to use when. And there's no steadfast rule that we're going to talk about in this class of what to use when. It's more just making you aware that in society, people are going to try and trick you and use things that aren't necessarily a good representation. All right, so that's what we just talked about here. So given the measure of central tendencies above, which is the best for this? And my opinion would be the mode, and because it shows that there were 2 averages. It shows that there were 2 averages for this class. There was the boys and the girls' shoe sizes. Okay. So we're going to do one more here, and then we'll take a break, and I'll see you in the next video after this. So one more. Let's wrap this up. When visiting Disney World, Florida, I learned this information. So take this with a grain of salt. This is what I was told. Disney World in Florida has one of the largest bus systems in the United States. They promise that a bus that should have a pay, not PIC. Nice. They promise that a bus will pick you up from any location on the Disney World property within 15 minutes of when you arrive at that bus stop. So that being said, they do not have any posted times. So they just tell you that one will arrive just within a 15-minute guarantee. If you are equally likely of waiting any amount of time within that 15-minute interval, how long do you expect to wait for a bus? So just to make sure that makes sense, what I'm saying with this equally likely idea is you are not able to kind of game the system and figure out any kind of schedule. It just means when you walk outside and stand in that bus stop, you are just as likely to have to wait 15 minutes as you are to wait 0, that bus is just going to be pulling up right when you walk out. It's just, or, you might have to wait 7 minutes. It's all equally likely. Okay, so what I want you to do is just get a feel. Just kind of think this through. What would you expect your wait time to be? Okay, how long do you think you would have to wait just if you were just completely at random? All right, take a minute, pause the video, think about it, and give it a shot. Okay, here's the idea. If you kind of think about it this way, you are equally likely to have any time period, and of course you could go to seconds. I'm just going to go ahead and kind of fill out a probability distribution table just for the fun of it. Whoops, I need a few more spaces. 10, 11, 12, 13, 14, and 15. There we go. Okay. Now, the probability of waiting 0 is the same as the probability of waiting 15. Is this same as the probability of waiting 4? Is the same as the probability of waiting 6? It's all the same, right? So therefore, I have a total of 16 different times that I could wait because 0 counts as one of them, right? So therefore, if I were to fill out this probability distribution table, it would all be 1/16th, right? 1/16th. So therefore, the idea here is the quote-unquote average wait time. If I one time had to wait 0 minutes, the other time had to wait 15 minutes, the average of those two would be 7.5 minutes, right? And then similarly, if I had to wait 1 minute one time and 14 minutes another time, The average of those would be 7.5 minutes. And if we keep working our way down, you'll realize what we're doing is working our way towards the middle, which would be right here. And which would be somewhere between 7 and 8 minutes, which would be 7.5 minutes. And that kind of makes sense, right? Logically, you expect to wait somewhere in the middle, right in the middle of the sometimes you wait none, sometimes you wait 15, so in the middle would be 7.5. So the expected wait time would be 7.5 minutes. Okay, now we're going to come up with a formal way of calculating this, but I just wanted to take you once through the expected value just to get a feel for it and what it means. So in the next video, we'll formally define it and we'll go from there. All right, see you then.